everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we are solving Leetcode problem number 152, which is maximum product subarray. So this is somewhat same as the other problem which we have solved earlier, which is maximum subarray sum with a cadence algorithm. So this is somewhat same as that particular problem. So with that, let us look into the statement of the problem. So given an integer array nums, find a subarray that has the largest product and return that particular product. Okay. The test cases are generated so that the answer will fit in a 32-bit integer. Okay. So if we see the constraints, the length of the array lies between 1 and 2 raised to 10 raised to 4, and any value in the nums array will be between -10 and +10. So what you need to keep in mind, so numbers will be negative and number can be 0 and number will be positive. So the product of any subarray of nums is guaranteed to fit in a 32-bit integer. So here we do not need to worry about the big number. So even if the product, whatever the product we get, it will be fit in 32-bit integer. That's what it says. Let us switch to our editor. So what is this problem? Basically, we have given any particular array, then what we need to do, we need to find the subarray. So what is subarray? Subarray is any part of the array which is contiguous. That means 2 can be one subarray, 2, 3 can be another subarray, 2, 3 minus 2 can be another subarray, and the entire array can be subarray. Okay. Next, 3 can be subarray, 3 minus 2 can be another subarray, 3 minus 2, 4 can be subarray. We cannot say like 2 comma minus 2 is subarray because this array is missing this particular 3 from the array. Okay, so basically there should not be any element missing in between, but it can be part of the array containing at least one number, and the numbers should be contiguous. Okay, with that, so we have to find a subarray which gives us the maximum product. Here in this particular example, if you see 2 into 3 gives 6. So this is the maximum product here. If you try to consider other numbers, say for example 2 into 3 into 2, then it will be -12. So -12 is the lower number, right? Negative number. So that we won't consider. Next, if you try to consider 4 as well, again it will generate still more negative number. So that cannot be our maximum product. Now if you see only 3 is less than 6, then 3 into -2, it is -6, again it is a negative number. Then if you consider the next number, again it becomes a negative number. So in this case 2 into 3 will give us maximum product. Okay, so how to find such maximum product here in this particular given array? Okay, so we understood what is the problem statement, and we also understood what are the constraints. So maybe you can pause for a second and you can think for any possible solution. Okay, with that, let us try to understand the idea or the intuition. So basically the interviewer will be expecting us to solve this particular problem in O of n time complexity and O of 1 space complexity. Okay, so if you have already watched my previous video, maximum subarray sum video, there you already know how to come up with the maximum sum. So it is a slight different variant, not exactly different variant. It is somewhat similar. There we were finding the maximum sum, but here we are trying to find the maximum product. Okay, so the brute force and the better solution will be same for this solution as well as the previous solution. Only the variation will be in the optimal solution. So I recommend you please go back and watch that video. I will be covering brute force and better solution as quick as possible in this particular video. So with that, let us try to understand the brute force solution for this particular problem. So what is the extreme brute force? So basically I will try to generate all the subarrays, something like this. Then what I will do, I will find the product and then I will try to get the maximum out of it. So if that is the case, how do we find the subarrays here? Basically, we need two loops. One, it points at a particular number, then we will take another pointer. So this is our start pointer and this is our end pointer. So whatever is there between our start pointer and end pointer, we will consider that as one subarray. Okay. In the next iteration, I will keep my start pointer at the same position. I will move my end pointer. So now we have two arrays between start and end pointer. Likewise, I will next move this pointer to the next. Then I will have three numbers. Then I'll move this towards right. Then I will have four numbers. Now, after this, now what I will do, I will move my start pointer to the second number. Okay, then I will again start my end pointer from the second number itself. So I will get 3. Then if I move this, I will get 3 and 2. Then again, if I move this, I'll get 3 minus 2 and 4. Likewise, I will generate all the possible subarrays. Then I will iterate over the subarray to find the product. Then I will come up with the maximum product. Okay, with that, let us try to come up with the pseudo code. So I need for loop. So for start equal to 0, start less than n will be basically length of the array, nums array, then start plus plus. Okay, so n will be nums dot length. Then I will take another variable maximum product and I will assign this with 0 maybe initially, or since we want maximum product, maybe I will say minus infinity, or minus the max, I mean the minimum possible value. So we can take minus infinity, I mean for the pseudocode, and we will see what exactly we take in our code. So with that, now what I will do, I will take another loop. Now this is our end pointer. Now our end pointer always starts from our start pointer, wherever start pointer starts. Then end less than n, end plus plus. Okay. Then whatever is there between our start and end pointer. So basically those two pointer, that is basically our subarray. Now what I will do, I will take another for loop for I equal to start, I less than or equal to end, then I plus plus. So this will basically iterate over the subarray. Then before that, I will take product equal to 1. Then I will say product equal to product into nums of I. Okay. In our previous problem, we took this particular as sum and we assigned it with initial value 0. But here we want, I mean, we should assign 1 because it is our multiplication. If at all we assign 0, then it will give 0 for all the multiplications. So with that, now I will get my product after the end of this particular for loop. Then what I will do, I will check my max product and I will update. Max product will be equal to max of max product comma our this local product, whatever we have found. So this way it will give us the maximum product. And if you see, we use 3 for loops. This is one, this is one, and this is one. So our time complexity will be O of n cube. Our time complexity will be O of n cube. And if you see, we are not using anything extra. That's why our space complexity will be O of 1. O of 1. But since this is n cube solution, this is extremely costly for us. So let's try to improve this. Let us try to improve this. Now, what we did in this particular problem, we used two pointer, say for example, something like this. Then what we did, we iterated over each value and then we found the product of all the numbers. But is that really required? So basically, this loop does that. But do you see, is it really required? Why? Because initially what we will do, we will take subarray 2, then we will take subarray 2 comma 3, then we will take subarray 2 comma 3 comma minus 2. Now in the first iteration you find the product of this subarray, then in the second iteration again you will end up multiplying all the values by iterating over each element. But that is not really required, right? Whatever you have found earlier, that you can take and simply multiply with 3, then in the next value simply multiply with the last value. So what I'm trying to say, this is not really required. So I will improve this. I will copy these two loops. Okay, I will paste them here. So now what I will do, I will move this a little bit down. Now I will say my product equal to 1. Okay, then here inside product equal to product into our nums of end. Correct, right? Then immediately after that what I will do, I will say max product equal to max of product comma max product. So this will update us the maximum product, and finally I will return my max product. Now if you see, we are able to find the maximum product in only 2 iterations. So if that is the case, our time complexity gets boiled down to O of n square. So this is our time complexity. This is the better solution if we compare to the first solution. And time complexity, space complexity remains order of 1. Order of 1. Okay, so this is how we boil down the time complexity. Now if that is the case, now for the best or optimal solution, we need to boil down this O of n square to O of n. Correct, right? That is what the interviewer will be looking for. So if that is the case, how to do that? So basically there are two optimal solutions. There are two optimal solutions. One is the cadence algorithm, what we discussed for the maximum subarray sum. So that is basically our cadence algorithm, right? So there is cadence algorithm like solution, that is one solution, and there is another one which uses like single iteration only, but we will try to find the prefix product, the prefix product and the suffix product. So these two algorithms will use O of n time complexity. So in this video, first we will look into the prefix and suffix product vein, how we utilize this particular logic. Then I will make another video for cadence like algorithm implementation in the next video. There we will also discuss what is the difference between these two algorithms and which one is most intuitive and which one to use when. Okay, so with that, let us try to come up with this prefix and suffix product way. So for that, now what I will do, I will copy this particular example. So now it is basically observation based solution. So what we need to observe, we already know our given array contains positive number, negative number, and also it can contain 0 because our number ranges between some minus value to some plus value. So if that is the case, it contains negative number, 0 as well as positive number. So if that is the case, the first condition would be all numbers are positive numbers. Here there is no issue. We can simply multiply all the numbers. So basically you take the entire array, you multiply all of them, and you will finally get the maximum product. This is one case. Next one is we have even number of negatives. Even number of negatives. It means when we have even number of negatives, they somehow after multiplication the final product becomes positive. So it is very clear for us. Now the third case, which is very important, the odd number of negatives. The odd number of negatives. We will take this entire example and we will try to come up with these all cases one by one and see. Then our fourth one is when it contains zeros. When it contains zeros in the array. So now this is straightforward, so we don't need to worry. This is straightforward, we don't need to worry. Now what happens if at all there are odd number of negatives? Say for example, out of this entire array, let us only consider this part. Okay, let us only consider this part. So which is 2 comma 6 comma minus 1 comma 5. Okay, or we can also consider the other part, which is this one, 8 comma 9 comma minus 2 comma 1. So let us consider only this part now. Now if you see, our maximum product will be 2 into 6, correct, right? And if you see, our negative number lies somewhere here and our maximum product lies towards its left, correct, right? Now if you see, again there is odd number of negative number here, correct, right? But I will make a little bit modification here. Instead of this one as to 9. Okay, this is for our understanding. Now if you see, our negative number lies here and our maximum product, it will lies towards right. So we are unsure whether our maximum product lies on the left side of the negative number or on the right side of the negative number. So in that case, what we need to do, we need to find the maximum sum on the left side and also on the right side. But if you are iterating over the array, how do you find that both the sides on the left side and right side? So for that, the simple way would be, you simply start from the left side and move towards right side. Simply keep on multiplying the number and try to get the maximum value. So if it lies on the left side, you will get on the left to right iteration. If the maximum is on the right side, you will get it on from the right to left iteration. So in this case, for first example, our maximum will be on the left. So we will get this max product when we iterate from left to right. So basically it is called prefix product. But if in this case, we get our maximum product whenever we iterate from right to the left. So this is basically, I mean, we call it as suffix product. So that is how we will try to get the maximum product by iterating from left to right once and from right to left once. So this is the main intuition behind this particular algorithm. So this is for odd number of ones, correct, right? We got to know what we need to do when it is odd number of negatives. But what if there is zero? Why the zero is a special case? Because if you multiply this with any number or any number, it will give us zero, right? Then we cannot really come up with the maximum product, correct, right? So in that case, now if you see, anyhow we cannot consider zero in any subarrays, because if zero comes, then the product will be zero. So that really does not contribute to the maximum product. So we will have to ignore this. So in this case, this becomes our one array. So either our maximum sum lies in this particular array or it will lies in this particular array. So whenever we come across zero, that time we will simply reset our prefix or suffix basically. So here, if we want to find the maximum in this left array or in this left part and in this right part, once we will have to move from left to right, then another time we will have to move from right to left, correct, right? So in such case, whenever we encounter 0, that time you simply reset. Why? Because this is one subarray, this is another subarray, which will contribute to the maximum product. Correct, right? That's where, I mean, you cannot include 0 at all in any of the cases. So you need to reset the prefix product or the suffix product whenever you encounter 0. Okay, with that, let us try to look into our pseudocode. So basically, now we will have n equal to nums dot length. Correct, right? Now what I will do, I will take prefix product equal to 1. I will also take suffix product equal to 1. Okay, with this, now I will use for loop for I equal to 0, I less than n, I plus plus. Basically, what we are trying to do, we are trying to iterate the array once from left to right and then again from right to left. So we don't need to use two for loops because it's a simple iteration, right? So once you process this number from left, then from right also you can process the numbers in the same array. How? I starts from 0, then you can also take this n value, and if you simply remove our I value, then you will get the last value. Correct, right? So at the same time you can start processing from the left and also you can start processing from the right. So I will use that logic. Then what I will do, first case is 0 case. So whenever our prefix product or suffix product becomes 0, so basically when you reach this point from the left or whenever you reach this point from the right, our product becomes 0. Correct, right? So that's what I'm trying to process. So if my prefix product equal to 0, then I will simply reset it to 1. Prefix product equal to 1. Okay, similarly for suffix product, if it is equal to 0, then I will say my suffix product will be reset to 1. If that is not the case, then I will calculate my prefix product equal to prefix product into nums of I, because this one I am traveling from left to right. Correct, right? Now I will take my suffix product and I will say suffix product into nums of, now this I should be n minus 1 minus I. Correct, right? Because I want to process from the last to first. Correct, right? So if that is the case, if I want to get the last index, then it should be n minus I or n minus 1 minus I. Minus I will be 0, so it starts from n minus 1 element. When I becomes 1, we will process the second element in the array, then this will be n minus 1 minus 1, so which is the second last element. That's how we process. So I will say n minus I minus 1. Okay, then finally I will update my max product, so it can be my prefix product or my suffix product, whichever is maximum. So I will say max of max product, comma, max of my prefix product, comma, suffix product. Correct, right? Then finally at the end I will return my max. Okay, so with this we will be able to solve this in O of n time complexity and O of 1 space complexity. Okay, let us execute this answer. So So I will take a variable constant n equal to nums dot length. Okay. After this, what we need let prefix product equal to 1, and also we need suffix product equal to 1. Okay. Then we need let max product equal to minus infinity initially. Then I will take a for loop for let I equal to 0, I less than n, I plus plus. What I will do, I will check if my prefix product becomes 0. What I will do, I will reset my prefix product to 1. Okay, I will copy paste the same. Then I will change prefix to suffix. So whenever our suffix also becomes 1, that time we need to reset it to 1. Now after that, our prefix product will be prefix product into nums of I. Okay, I will copy paste. Wherever prefix product is there, I will change it to suffix product, but this should be n minus 1 minus I. Next, I will update my max product. So math dot max of max product, comma, again math dot max of prefix product, comma suffix product, because out of this whichever is greater, that I will take and I will compare with the existing max product. Then finally I will return my max. With this I will run and see. So our solution got accepted. I will submit. If you see, our solution got submitted successfully. So this is one of the optimal solution, and this is a clean and clear way of solving this particular problem. So we will see one more way, which is Kadane's algorithm like way, in the next video, and also we will discuss the difference between this and the other algorithm in that particular video. Hope I was able to make you understand this particular algorithm. If that is the case, please consider uh, subscribing to my channel, and also like the video, share this with your friends, and also if you have any queries or if you have understood it well, you can add that as a comment. Thanks for watching.